So welcome to Cycle 2, Lesson 2.1, Introduction to Algebra and Collecting Like Terms. So the goal for this lesson is to identify and describe characteristics of a polynomial. So in algebra, we use letters to represent unknown quantities. The letters are what we call variables. Okay, and to understand the meaning of the word variable, this means something that changes. Okay, we're not going to be stuck to just one number. No, the number can now change, and it's called variable because that number is changing. Some other definitions that we need to understand. Well, a term. Okay, so next we're going to use this word called a term very often. So a term has a coefficient. And one or more variables. So an example of this would be something that looks like 2x, or even something that looks like this, negative 4, x squared, and y. So here, 2 is a coefficient, x is a variable. Here, negative 4 is a coefficient, x and y are variables. So what exactly are these things called coefficients and variables? Well, coefficients are the number in front of variables. Okay, these are the numbers that come before the variables. In front meaning as we read from left to right, the first thing we see is the thing in front, which is the coefficient 2. Here, as we read from left to right, the thing in front that we see here is negative 4. So the coefficient is always the number in front of the variables. The variable is the letter or letters used to represent unknown values. Okay, unknown or even changing values. And the degree is the sum of all variable exponents in a term. Okay, so what does the degree mean? If you look at 2x here, well, the x is an invisible of exponent of 1. So that 1 means that the degree of this term is 1. Here, negative 4x squared and y, well, my variables are x and y, so the exponents are 2, and the invisible exponent for y, which is 1. So 2 plus 1 is my sum, and 2 plus 1 is 3. So the degree of this term would be 3. Okay. So let's complete the following table. 2x cubed, so the coefficient, so I read this 3 is cubed, this 3 is reread as cubed, so 2x cubed. The coefficient here is 2. It's the number in front of my variable. Okay, the variable itself is x, so it's going to write here x. Don't write cubed, it's just the x, right? And the degree, well, the sum of all the exponents of my variables in this term is 3, so the degree is 3. Okay, we're not counting any invisible exponents of the coefficients, just the variable. Negative 4x squared y to the power of 5. Here my coefficient is negative 4. My variables are x and y. And the degree is, if I sum these exponents for my variables, 2 plus 5, the degree is going to be 7. So 2 plus 5 equals 7. Next one. Your variables don't have to be x and y. They could be different letters. So a is a variable here. The coefficient in front of that a is 5. And the degree, well, the invisible exponent is 1, so my degree is 1. T to the power of 6. So sometimes we use t as a variable, and t can denote time if in an application problem. T is time. So t is my variable. And my coefficient, if you see no number in front of the variable, then the coefficient is that invisible 1. So that's the 1. And my exponent here is 6. And since there are no other variables, that means my degree is going to be 6 for this term. And my last one, coefficient, is -1. That's the constant value that you see. It includes negatives as well. Variables, there's nothing changing here in this term. The term is just -1 all the time, no matter what you do. It's always -1. So I'm not going to say there's any variable here. And the degree is going to be 0 because there are no variables, meaning there are no exponents for those variables, so the degree is 0. It's a constant term. So a constant term is what we say is only a number no variables. So if there are no variables, it's hence we say never changing. It is always constant. Okay, so again, this chapter is full of new definitions. This first lesson is full of new definitions. So the next one is going to be polynomial. The definition of polynomial can be a single term or a combination of terms. When you have a combination of terms, they are separated by a plus sign or a minus sign. So an example could be of a polynomial could be this. So 4x squared, there's one term there. Another term would be 3x. I'm going to separate this with a minus sign. So 4x squared minus 3x plus 5. So here I have a polynomial with 1, 2, 3 terms. Now polynomials can be classified by the number of terms it has. So a monomial would be a polynomial with one term. Example, 4x cubed. Then we have a binomial, which is a polynomial made out of two terms. An example would be 4x cubed plus 3x squared. Then we have trinomials. These are polynomials that specifically have three terms. An example could be 4x cubed plus 3x squared minus 2x. And then we have, in general, we'll just say polynomials. So polynomials can be many terms. So more than one term. So we'll just say here, in general, if we have more terms, it could look something like this: 4x cubed plus 3x squared minus 2x plus 1. Okay. We can also classify polynomials by its degree. Okay, the largest sum of exponents in any one term. Okay, so if you see, if you have a term here with the largest exponent 3, then we could say this is a polynomial of degree 3. Right? So let's look at a few more examples to illustrate this. So I'm going to give you the polynomial. You're going to tell me the number of terms and its classification and its degree. You could pause the video for a moment and try this yourself. Okay, so if you tried it yourself, let's go over what each of these are. So we have here three terms for x squared minus 3x plus 8. So this is a trinomial. What about its degree? Well, if you look at each of these terms, you look for the term with the variable with the highest exponent. So I have an x squared here, and I have a 3x. The x squared is much higher, so I'm going to use this term here, and this term is going to tell me that this entire polynomial is of degree 2. An exponent of 2 means we have a degree of 2. Okay. The next one. Now here I have a single term. There are no other plus signs or minus signs. It's a single term with several different parts. So I'm going to call this the monomial. Okay, and if we look at the degree, remember there's an invisible exponent of 1 for the x, and I have an exponent of 6 for the y. So 6 plus 1, I have to take their sum. That will give me the degree. So that's going to be a sum of 7. So 1 plus 6 equals 7. Degree 7. Next here I have two terms separated by a minus sign. So that's going to be called a binomial. and the only variable term here is x with an exponent of 5, so the degree is 5. The last term here, we have a polynomial of 4 terms. There's no specific name for that. I'm just going to say this is polynomial. And we have here a term with x cubed. There are no other terms with variables with a higher exponent. 3 is the highest exponent, so the degree is 3. Okay, let's move on. Like terms. So like terms are like if they contain the same variables with the same exponents. Okay, so term 2a, what are some other terms that could be like terms? They have to have the same variables with the same exponents. So if I'm going to have any other term, it's going to have a in it, but it cannot have a squared, it cannot have a cubed, it's just a. It cannot be b, it cannot be x, it cannot be y, it has to be just a. So all I have to do is just write down the a and change the coefficient, and I would have a like term. So here's some examples. For a, I can have -5. I can have negative numbers as my coefficient, and then a, and then 1/2 times a. Okay, make sure that you have to have a. It can't be a constant value either. What about y to the exponent 5? Same idea, just change the coefficient. So 4 times y to the power of 5 is a like term. -7 times y to the power of 5 is a like term. 100 times y to the power of 5 is a like term. And 1/8 times y to the power of 5 is a like term. Okay, so they must have the same variable with the same exponents. And it could be more than one variable too, so keep that in mind. So circle the group of like terms. So between x, 3x, 4, 5x squared, and -6x, circle the like terms. So here I have a variable x, here I have a variable of x, and here I have a variable of x. I'm going to circle these 3 terms. 5x squared is not a like term because it has a different exponent. And 4 is not a like term because it is a constant value with no variable. Number 2, what are my like terms here? Well, it looks like it's going to be the like terms that all have a single y variable. So 4y, 10y, 2/3 y, and -1y, or negative y. The only one that's not included is the variable with the y squared. Okay, so you can still have like terms even if you have fractional coefficients like 2/3, and even if you have coefficients with just a negative in front. Number 3, what are my like terms? Well, it seems like it's going to be the x squared terms here. So -x squared and 4x squared. Is x going to be part of it? No, because it has a single exponent of 1. X cubed is going to be part of it? No, because the exponent is 3, which is different than 2. What about y squared? It has the same exponent, 2 and 2, but it can't be like term because it has a different variable, y. Number 4, what about more than one variable? Well, it sure can happen. A squared b. So now I'm going to look for other terms with an a squared and a b. Here I have a single a and a single b. That doesn't work. Here I have a single b and an a squared. So this one works as well. Negative coefficient is fine. And the ordering does not matter either, as long as it's the same variables with the same exponents. Okay. If it was b squared a, that would not work. Okay. It has to be a squared and b. Here again, I have a squared and b, so I'm going to circle that. And here I have an a squared and b, so I'm going to circle that. Algebraic expressions can often be simplified by adding or subtracting like terms. And this is the entire point of trying to understand what like terms are. So this is called collecting like terms. Okay, we do this by adding or subtracting the coefficients. Okay, so let's show you how this works. I'm going to simplify the following. So let's look at our like terms. I have a 10x and 3x. These two are like terms. Okay, so I can simplify them by adding or subtracting their coefficients. So if I have a 10x and a 3x, well, I can add their coefficients together because they're both positive, 10 and 3, to give me 13. I also have -4y and plus y. Okay, and I can also add their coefficients because these are like terms with the same variable. Often, sometimes in the beginning, it helps to put everything in order first. So, you put 10x, put the other x in front, so plus 3x. Just change these two around, so I have minus 4y plus y. But this isn't necessary unless if you understand everything that's going on. So all I'm doing is I'm just adding the coefficients, 10 plus 3, and I have 13x. And then I'm going to add the coefficients for these two like terms here. So negative 4 plus, don't forget there's an invisible 1. So negative 4 plus 1 is negative 3y, or minus 3y. Okay. So as long as you obey the signs and you recognize your coefficients, then you can collect like terms. Part B, same idea. So what are my like terms here? I have the 4p squared and I have the minus 5p squared. So if I combine these two, I just subtract these like terms. So 4 minus 5 gives me negative 1. So this equals negative 1p squared. So I normally don't write the 1 if it's just a 1. So negative p squared is fine. And then I have these other like terms here, the plus p and the minus 10p. So again, invisible coefficient of 1 in front of the p. So 1 minus 10 is negative 9, or I can say here minus 9p. Okay, so again, my final result is still a expression with two terms being separated by a subtraction sign here. And I cannot combine these two terms because these are not like terms. One has a p squared and the other has a p. All right, looking at C, I'm going to just go through these ones a little bit quicker now. So collecting like terms, let's collect the x terms. So 3 plus 4 is 7x. I have a lone 7y over there. And I have my constant terms. So you have to collect the constant terms as well. So minus 4 minus 5 becomes minus 9. Minus 4 take away 5 is minus 9. And over here, what are my like terms? A's and B's and the constant. So collect the A's. So 3a, take away an A, take away 7 more A's, gives me negative 5a. What about the B's? So 5 B's, take away 6 B's, gives me negative 1b, or I'll just say minus b. And then I have here negative 14 and plus 4. So negative 14 plus 4 gives me negative 10. And there you go. Last one here. Quite a bit more complicated. So take your time with it. Look at the terms that are like. So I have 6st squared. So I have to find in the rest of this polynomial here what looks like s and t squared. Here I have st. Here I have ts squared. Not like terms because they have same variables but different exponents. I have to keep looking. 10, nope. 5s, no. 3ts, no. 8ts squared. There's a t and s squared. Nope, still not work. Different exponents. Down here, though, we have t squared and s. Same exponents. The order doesn't matter as long as you have the same variable with the same exponents. So t squared matches with the t squared here. S matches with the s. So these two are like terms. I'm going to add their coefficients. So 6 plus 3 is 9. Now, it doesn't matter which order do I write them. I can just write this as st squared. I'll just follow what I see in the beginning, the first one here, and keep s in front of the t. Okay, next I have plus 4st, and let's look for another one. So I have a plus 3sts here. So again, the ordering just changed, but the same variables, same exponents, so I can combine them. So 4 plus 3 is equal to 7. So s7 st. Then I have a minus 3ts squared and a minus 8ts squared. And when I combine those two, I get a minus 11 ts squared. Okay. Now, if I was following conventions, I would just, keeping my ordering, I'll just keep the s in front. So I can say here s squared t. Because in the other terms, I kept the s in front. So I'll just keep it consistent. And then I have my s. So minus 5s. There are no other s terms to combine with that. And then I have 10 and minus 4, which makes positive 6. Okay. Now, one last thing I'm going to say is that generally speaking, if I choose to make s the variable in front, it's always a good idea to put your exponent with the highest exponent term first. So I'm going to put the negative 11s squared t first. So negative 11 s squared t. Then I'm going to put my plus 9st squared, and then I'm going to put my plus 7st, and then minus 5s plus 6. So generally speaking, you should put your terms in order of the highest degree. Okay, so these two terms are degree 3. This term is degree 2. Here I have a degree 1, and here I just have my constant term at the end. Okay, let's do an application example number 2. Determine an expression for the perimeter of the triangle and determine the perimeter given x equals to 2. So what's the perimeter? If you recall, perimeter is just the total length path around the shape. And I'm giving you the lengths of each of the 3 sides. So what I have to do is add all 3 sides. I'm going to be adding these 3 polynomial expressions. These are all trinomials. Add these 3 trinomials. So I'm going to have 5x squared minus 10x plus 2. Okay, that's this first one here. Then I'm going to add 8x squared minus 3x plus 1. I'm going to keep this in brackets for now because you're adding an entire length side. Okay, you got to make sure the signs are going to be obeyed. I'm going to be adding the third side, so negative 2x squared minus 7x plus 3. Okay, collect your like terms. I have a 5x squared, 8x squared, and a minus 2x squared. Add their coefficients, so 5 plus 8 minus 2 is 11x squared. And we'll express here p is equal to the perimeter. And then I have the x term, so negative or minus 10x, take away 3x, take away 7x, gives me minus 20x. And then my constant term, so 2 plus 1 plus 3 gives me 6 plus 6. So there's my simplified expression for the perimeter of this particular triangle. Now I'm asked to find the perimeter given x equals 2. So what I have to do is replace my x, this variable, with 2, and I'll find my perimeter. So the perimeter at x equals 2 is equal to 11, replace x with 2, put it in brackets, so 2 squared, minus 20, replace x with 2, put it in brackets, plus 6. This equals BEDMAS rules, so 11, 2 squared is 4, so I'm write that 4 first. 20 times 2 is 40, and then I have plus 6. Then you do your multiplication. 11 times 4 is 44, minus 40 plus 6. And when you simplify these last 3 terms, the perimeter is going to be 10. And in the absence of units, I'll just leave it unitless, but if I said if x was 2 centimeters, then you'd have to write your answer in centimeters. All right, and that is the lesson for 2.1.